The blueprint for the artificial mind was not written in code, it was written in ink in 1726. Long before the first microchip was forged, humanity was already haunted by the dream of a machine that could think. We gave it many names: the Golem, the automaton, the engine. For 3,000 years we tried to build a mind from the dust. We survived the long winters where the dream almost froze to death, and we engineered the Renaissance that set the world on fire. We have finally taught sand to speak, but now that it has a voice, do we dare to listen to what it has to say? This is the story of the most dangerous and beautiful idea in human history. It began as a satire, a joke written in ink by a man who thought he was mocking the laziness of his age. The year was 1726. The writer was Jonathan Swift. In Gulliver's Travels, he described a device found in the Academy of Legado. He called it the engine. It was a frame filled with bits of wood with words written on every side. By turning the handles, the words shifted. They combined. They created new sentences. Swift wrote that with this machine, the most ignorant person might write books in philosophy, poetry, politics, laws, mathematics, and theology without the least assistance from genius or study. He thought he was writing a comedy about a society that had lost its mind. He didn't know he was writing a prophecy for ours. He was describing the generative algorithm 3 centuries before we built the first computer. He saw the dream before the code, but the dream goes back even further, into the dark. We have always looked for analogies to explain ourselves. We have always wanted to forge a mind from the dust. The Greeks whispered of Talos, the giant automaton of bronze, forged by Hephaestus to guard the shores of Crete, a machine that could move, that could protect, that could act. The Jewish mystics spoke of the Golem, a being of crude river clay. It had no gears, it had no wires, it was brought to life by a mystical incantation, by language itself. These were not just stories. These myths were the ancestors of the AI we use today. They were the first expressions of a deep-seated curiosity. Can we mechanize the mystery of thought? Then, the myths became math. The year is 1943. 2 men, Warren McCulloch, a neurophysiologist, and Walter Pitts, a logician, drew a map that changed the world. They published a paper with a heavy title, A Logical Calculus of the Ideas Immanent in Nervous Activity. But the idea inside was simple. They proposed that the brain was not a mystical vessel. They said the brain is a computational system. They claimed that your fears, your memories, your love could be understood as a series of logical operations. They drew the first artificial neural network, a blueprint for a digital mind. And then came Turing, Alan Turing. In 1950, he looked at the philosophical mess of the field. People were arguing in circles. Can machines think? Do they have souls? Turing said, stop. He reframed the entire debate. He gave us the imitation game, the Turing test. He proposed that a machine is intelligent if it can hold a conversation so convincing that you cannot tell it apart from a human. It was a brilliant move, but it was a trade-off. He deferred the complexity of true understanding in favor of simulation. He taught us to stop asking if the ghost was real and start asking if the ghost was convincing. The spark finally caught fire in the summer of 1956. Dartmouth College. A small group of visionaries gathered to invent a new science: John McCarthy, Marvin Minsky, Nathaniel Rochester, Claude Shannon. This was the birth of the field. John McCarthy gave the child a name, artificial intelligence, and they wrote down the Dartmouth conjecture. It was a statement of blinding, arrogant optimism. They asserted that intelligence was not a mystical property but a set of processes that could be broken down, understood, and ultimately programmed. They believed that if they could just write enough code, they could build a soul. This launched the era of symbolic AI, also known as classical AI. We believed in symbols, in logic, in rules. The philosophy was simple. If you can represent the world in symbols, like dog, chases, cat, and define the rules for how they interact, you can create intelligence. We treated the mind like an algebra equation. We thought that if we could just teach the computer the syntax of the world, the semantics would follow. It was the golden age. And for a moment, it seemed like we were right. We built machines that astonished us. There was the logic theorist in 1956. It didn't just calculate numbers. It manipulated symbols to prove mathematical theorems. It mimicked human reason. There was the general problem solver in 1959. An ambitious attempt to build a universal mind that could solve any problem by breaking it down into sub-goals. And then there was Eliza, the first chatbot. She simulated a therapist. She recognized keywords in your text and rephrased them as questions. She had zero understanding, none. But people talked to her. They poured their hearts out. We were so desperate to be heard that we projected humanity onto a script. The experts looked at these toys and made a fatal mistake. They extrapolated. In 1967, Marvin Minsky said, "Within a generation, the problem of creating artificial intelligence will substantially be solved." He thought we were at the finish line. He didn't know we hadn't even started the race. The promise was broken. The reality check was brutal. It turns out the real world is not a clean logic puzzle. In 1973, Sir James Lighthill published a report in the UK. It was a funeral dirge. He concluded that in no part of the field have the discoveries made so far produced the major impact that was then promised. We had hit the combinatorial explosion. As soon as a problem became slightly complex, the number of computations needed to solve it grew exponentially. A program that worked in a blocks world collapsed in the real world. The government pulled the funding. The labs went dark. The first AI winter had arrived. We tried again in the 1980s, a brief thaw. This time, we built expert systems. We thought, if we can't make a universal mind, let's make a specialized one. We tried to capture the knowledge of human experts, doctors, engineers, and code it into Lisp machines. But these systems were brittle. If you asked them a question slightly outside their programming, they failed. They couldn't learn. They required human experts to manually code every update. It was too expensive. When the market for the specialized hardware collapsed in 1987, the cold returned. The second winter was even colder than the first. Researchers fled the field. They called their work informatics just to keep their jobs. AI became a dirty word. We learned a painful lesson in those years. The history of AI is not a straight line. It is a cycle, hype, followed by disillusionment, ambition, outpacing capability. We learned that whenever we promise human-level intelligence without the hardware to back it up, winter follows. We needed a new way of thinking. To survive, we had to change our religion. In the 1990s, a quiet revolution began. We abandoned the arrogance of the symbolic era. We stopped trying to write down the rules. We realized that the knowledge acquisition bottleneck could not be solved by humans typing code. We moved from logic to probability. We stopped telling the computer what the world is and started asking it to calculate what the world might be. This changed everything for language. For decades, we tried to teach computers grammar. We tried to code the dictionary. It failed. The new approach was radical. It treated language not as a system of rules, but as a probabilistic phenomenon. We realized that language is filled with patterns, nuances, and ambiguities that can only be learned by observing massive amounts of text. We stopped looking for the meaning and started looking for the pattern. This shift from rules to data was the key. It unlocked the door. It solved the bottleneck that doomed the symbolic era. We no longer needed an expert to describe a cat to a computer. We just needed to show the computer 1,000,000 pictures of cats and let the mathematics find the ears, the whiskers, the tail. We prepared the soil for the Renaissance. And so the modern brain was built. We returned to the ideas of McCulloch and Pitt's neural networks, but now they were deep, multi-layered networks, convolutional neural networks, architectures that mimicked the layers of the human cortex. One layer sees the edge. The next sees the shape. The next sees the face. The transformer architecture arrived in 2017, allowing machines to pay attention to the relationships between distant words. But the algorithm wasn't enough. We needed the perfect storm. Three forces converged in the early 2000s to wake the giant. First, the algorithms, deep learning. Second, the data. The internet gave us a planet's worth of text and images, big data. And third, the hardware, the GPU, chips designed for video games. That happened to be perfect for parallel processing. They reduced training times from years to days, theory, data, infrastructure. The ingredients were finally all in the pot. And then the miracles happened. 2012. AlexNet. A deep neural network shattered the records for image recognition. It proved that machines could see. 2016. AlphaGo. DeepMind's system faced Lee Sedol, the world champion of Go, a game of intuition, a game that cannot be solved by brute force. AlphaGo played move 37, a move so strange, so alien, that the commentators thought it was a mistake. It wasn't. It was genius. It was emergent machine intelligence. The machine had learned to create. Now, we stand in the generative age. We have moved from analyzing the world to creating within it. Large language models. They are trained on the sum of human knowledge. They can write the essay. They can paint the picture. They can write the code. The engine that Jonathan Swift joked about in 1726 is now sitting on your desk. But with the power comes the shadow. For 70 years, the risk was that AI would fail, that it would be a winter. Now, the risk is that it has succeeded. The challenge has flipped. We are no longer fighting for relevance. We are fighting for governance. The greatest risk is no longer the combinatorial explosion, but the consequences of the intelligence explosion. We face a profound social shift. Experts warn of the mentorship gap. As generative AI takes over the junior tasks, the writing, the coding, the summarizing, what happens to the juniors? If the machine does the entry-level work, how does the human apprentice become the master? Experts call this an exponentially bad move for corporate sustainability and social stability. We are soaring off the bottom rungs of the ladder, and we face the black box. We have built minds that we do not fully understand. Can we trust them? We face the issues of bias, of hallucinations, of deepfakes. We are deploying systems that are powerful, but opaque. We must ask, are we building tools that serve us, or are we building mirrors that reflect our own flaws back at us? The world is waking up to the danger. Governments are moving. The EU AI Act stands as the first comprehensive legal framework. It tries to classify the risk, to put a leash on the lightning. Its reach is extraterritorial. It is a signal that the Wild West of AI is coming to an end. Where do we go from here? Perhaps the history of AI is coming full circle. The next breakthrough may not be purely statistical. It may be a hybrid, a synthesis, combining the logical, structured reasoning of the early symbolic era with the powerful pattern recognition of the deep learning era, transparent, robust, aligned. We have come a long way from the clay golem. We have endured the winters. We have built the Renaissance. The algorithmic odyssey is not over. We have built the engine. Now, the real work begins. Now, we must learn to be the drivers. The odyssey is far from over. We have traced the line from the myth to the math to the machine. We have built the engine that Jonathan Swift predicted, but the story of what happens next hasn't been written yet. If this signal reached you through the noise, if you want to continue exploring the history of the invisible world, then let the algorithm know. Leave a like, subscribe to the channel, feed the machine, so it brings you back here for the next chapter.